As developers, we spend about 99% of our time just trying to make our code work. We build out the features, we tweak the performance, and we meticulously chart out those happy paths. But what happens when it all breaks? Well, in this explainer, we're going to radically shift our mindset. We aren't just going to focus on making code run anymore. We're going to focus on making it fail securely against cyber attacks. Because, let's be real, in a production environment, an unhandled error isn't just a tiny glitch. It is literally an open door for an attacker. So here is our roadmap for today's explainer. We'll hit Section 1, Beyond Basic Error Handling. Then 2, The Danger of Uncaught Exceptions. 3, Deadly Exception Anti-Patterns. 4, Defense Tactics by Language. And finally, 5, How to Fail Securely. By the time we wrap this up, your code won't just run, it's going to be bulletproof.
Okay, let's dive into this with Section 1, Beyond Basic Error Handling. To really get this, we need to understand the fundamental difference between customer service and internal security. It's kind of like two sides of the same coin. On one side, we have basic error handling. This is all about the user experience, right? It's making sure that when something inevitably goes wrong, your user sees a friendly, safe, generic message instead of a terrifying block of stack trace. But on the flip side, we have exception management. This is what's happening deeper down in the trenches. Exception management is entirely about code behavior. It's about ensuring your application recovers safely from runtime anomalies and actually maintains a secure state. Think of it this way. If an unhandled exception bubbles all the way up to your framework's default error handler, you have completely failed at exception management before error handling even got a chance to step in. Moving right along to Section 2, The Danger of Uncaught Exceptions. Consider this a tactical briefing on the battlefield of runtime anomalies. Why exactly are these such a massive threat to our systems? Well, the stakes here are incredibly high. Uncaught exceptions don't just crash apps. First off, they crash right through to the framework's default handler, which unfortunately often happily exposes detailed system information directly to the user. And second, attackers know this. They will absolutely deliberately trigger exceptions, like sending malformed input or requesting invalid resources, just to gather intelligence about how your system is built. Third, these exceptions leave resources in a totally inconsistent state. We are talking open database connections, unreleased file handles, uncommitted transactions, the whole shebang. Your application might technically still be running, but it's running in a corrupted state that is basically a ticking time bomb for massive cascading failures down the line. Which brings us to Section 3, Deadly Exception Anti-Patterns. It's time to expose the real villain of our story here. And surprisingly often, the biggest threat to our application security is our own lazy coding habits. I want you to think about this question for a second. We all know uncaught exceptions are bad, so naturally, we wrap our code in a try-catch block. But what actually happens when we catch an error and then do absolutely nothing with it? Yeah, that exposes one of the most dangerous anti-patterns in all of software development, the empty catch block. Catching an exception and doing nothing, no logging, no recovery, nothing, silently swallows the error. Your app just keeps running as if everything is perfectly fine, but something did happen. Maybe a critical database write just failed and data is lost forever. Or worse, maybe an authentication check threw an error, and because you swallowed it, the system just granted access by default. If an attacker is repeatedly probing your system with SQL injection attempts, those exceptions are your only warning signs. If you swallow them, you are literally giving attackers the perfect cover to map out your vulnerabilities undetected. Listen, at an absolute minimum, you must log the exception. And this brilliantly illustrates our next major vulnerability, information leakage. Just look at that raw exception at the top. If you pass this exception message directly back to the client, you have just handed an attacker exactly what type of database you're running and the exact name of a table. You never, ever want to hand out your internal blueprints. Instead, as you can see at the bottom, log the full raw details internally on the server for your team, but return a sanitized, completely generic message to the user. We also really need to talk about maintaining an unbroken chain of defense regarding our resources. So if you open a database connection in step 1 and an exception occurs in step 2, you simply cannot rely on the happy path to close that connection. If your cleanup code gets skipped, you're going to leak connections until the pool is entirely exhausted, and Boom, you've got a deadlock. This is exactly why step 3 is non-negotiable. You must use your language's appropriate mechanisms, like try finally blocks, to guarantee that cleanup happens no matter what kind of exceptions get thrown. You just have to assume exceptions will happen and plan your cleanup accordingly. All right, section 4, defense tactics by language. Let's shift from universal concepts to some concrete tactics and see how we actually implement these defenses depending on what language we're writing in. So if you're writing Java, your first rule of thumb is to catch specific exceptions, like a SQL exception. Never just catch a generic exception, because honestly, a database failure requires a completely different recovery strategy than an I/O failure. Second, you always want to use try with resources for anything that implements auto-closable. This just handles your resource cleanup automatically, which is fantastic. You can also use the @exception handler annotation in Spring to map exceptions securely to HTTP responses. And finally, never, ever catch Throwable. Throwable catches JVM-level errors, like out-of-memory error, and frankly, your application absolutely cannot meaningfully recover from those. Just let them crash loudly so they can actually be fixed. And now, for the Python developers out there, the principles are very similar, but the tools are a bit different. Again, you want to catch specific types like value error or IO error, definitely not a bare accept. For guaranteed resource cleanup, you should rely heavily on the with statement in context managers. When you log, use logger.exception. It is a real game changer because it automatically grabs the full traceback for you. And if you ever need to re-raise an exception, always use raise from so you preserve that exact traceback chain for debugging later on. JavaScript, of course, has its own unique quirks, especially when we get into asynchronous code. If you're using async await, you must always wrap your awaited calls in a try-catch block. This is absolutely crucial because in newer versions of Node, an unhandled promise rejection will completely crash the entire process. No joke. Make sure every single promise chain ends with a .catch. If you're using event emitters, they must have error event handlers attached, otherwise they just throw and crash your app. And if you happen to be building an API in Express, remember that async route handlers that throw an error need to explicitly pass that error along using Nexter. Which brings us to our final section, section 5, how to fail securely. We know how to catch errors and clean up resources now, but how do we guarantee that our system maintains a secure state no matter what fails? So the crucial point is really perfectly mapped out in this cheat sheet. Every exception must lead to a secure state, period. An authentication exception, access is denied, full stop. An authorization exception, you return a 403 forbidden, but you give absolutely no additional details about why. A validation exception, return a 400 bad request, but only describe what was wrong with the user's formatting, not what your internal system was actually expecting. And for an unknown exception, something you didn't anticipate at all, return a 500 internal server error with a completely generic message to the user while logging the absolute life out of it on the back end. Your system has to degrade gracefully. If you take only one thing away from this entire explainer, please let it be this golden rule right here. Log everything internally, reveal nothing externally. This is the absolute core philosophy of modern exception management. I want to leave you with this final, somewhat provocative thought to review against your own production code today. When the unexpected happens, and trust me, it will, is your system gracefully degrading, or is it handing the attacker its internal blueprints? Exception management might not be the most glamorous part of coding, I get it, but it is the invisible shield that keeps your application safe when everything else goes wrong. So go check your catch blocks, sanitize those outputs, and make absolutely sure you are failing securely.